Hello everyone! I was just watching this prime time again. It was just like an hour ago. Now it says 2 hours ago, but I don't think it's past. And there was this very interesting topic of the 4 billion if statements. It's generated code. It's basically the you know this kind of code, like telling if a number is odd or even, and generating all the if statements for that, for all the 4 billion possibilities. And I just was quick to react. I was say very okay. How to see this? Music I will put in the description. It's my friend's band. Actually, my bro was playing in it. So I already reacted like 22 minutes ago that I know a more optimal solution. Of course, everyone knows a more optimal solution just by checking a modulus or by ending with 1 or something like that, or arithmetics. But to literally make that many if statements in the code, I also know a better solution by basically putting as that many switch case statements. And that would be like, I imagine that it would be like much faster. The original guy's code was basically it took 10 seconds for him to run that code, and it became like a 40 gigabyte file to move into memory and memory map and everything. And I think we can do better. Literally, I am pretty sure we can do better. And I don't have that much memory anyways. So my proposition is that why not leave code this here? So I imagine that the isOdd function should be like jump here to this something plus eax number 3, because 3 bytes is all what we need for each switch case, like the case statement. And we will just erase the eax register if the register is like if it's not odd, so it should return 0, which is false because it's not odd. And otherwise it should do something else, like either XORing some other register with the same amount of bytes, or maybe just put two operations there. And here are the opcodes that we will do, and some prefix. And I already answered like, okay, I went into some disassembly, and I know these are the opcodes for the relative jump to the eax from here, and the code. So it's pretty easy to generate, and it should be like these few bytes, like 2, 4, 6, 7, plus 3 times 3 billion. The 3 billion bytes is like 3 gigabytes. So it should be around 12 gigabytes plus 7 bytes actually, which is much smaller than the 40 gigabytes of the case of our friend. Not prime time, he just watched this blog post, but I found it very interesting. Anyways, I just realized that he now cannot like make the video faster. I don't think he will react to this anyways. So that's what we will do. For that, I went to this, just Googled a little bit, like how to make a memory map something executable with mmap. And here are a lot of boilerplate code for Android, which is like nearly Linux. So I just thought, let's grab this. It was C++ instead of C, so it was like, even though using printf and this kind of old style, like nearly C style, it was C++ because it has like interpret casts and stuff. So I just made a C version here, and so this is the C version, and this just has a lot of to-dos in it, like to do jump to the mmap region and the load the instructions into the memory. We can actually generate the instructions on the fly here, because why not? Or we can like generate them into a separate file, as the guy was doing it. Or we can actually just do like, let's do this. If argc is bigger than 1, then we will just generate the file. Yeah. Because why not? It's very simple. Yeah, just do it like this. And generating the file would be like this. Ah! Do we really need that? I'm really thinking if we really need that or not. Because, what the hell? Maybe it's better to generate it in memory. Why not? Like, we can do that. Like, you know, we could store it in a file, but who cares? So let's do it. We have a memory, and don't like it that way. Okay, just do it in the file, because then I can demonstrate the binary that's generated. So instead of having a Python code to generate something, or a C++ code to generate something, and then a code that loads it and runs it in memory, we just do the whole application in one code, source code, and the generate will be here. Okay. So it will be here, and my point is it should like open something for write. Yes. Why not? Okay. So it should be like open data file, and then we should just not use printf but binary writes, which we should Google out. I didn't want it this, but like okay. Just do F right. Okay. stdio. Stir. Okay. Mode. Okay, that's very simple. It will be just write. Okay. Like we will do not current car, but we will do 0x. I will just copy it from here. just one type. Okay. Okay. Yeah, so this is basically this is what we are writing, eax, and then in a loop I just hope that works, but it will. And what we're doing here is that we're just f-right. Three bytes. Oh. Okay, I will just do it this way. No. I can just do it. It's simple. So, if so here we are already writing the program that actually should be just the program. So we are writing this in a much more complicated way, but you know, it's just fun time and jokes and happiness. Anyways, so we are generating odd, generate even, and odd should be like nope 1990 C3. Okay, and even should be like 31C0. Let's write it here. Nope. Right. Here we should write like so. And that looks to be all. So we can just F close. For the fun of it, why don't we do? We had like not equals to null. Maybe this is it looking better. Actually do f puts, because why not? So, what this is that it generates the data file, which should be like very huge. Let's test this. Something is. Ooh, that would be very bad because this needs a pointer, isn't it? Yeah. Ooh. That sounds really bad, but we got thank you. So instead of these f writes, what we should do let's do it this way. Let's capture. Let's do this, because why not? Okay, so for all f writes, we should just exchange them with car C. Oh, I don't want the 0x there. We should just do it his way, because then I can do this. And then it should be like 0x that. And then a new line, 2 tops, because then at least I need to write fewer of them. And then the f write C/1, and I just put in the space there. Yes, no, yes, I have put it there. Can just do this. And yeah, maybe that's all. Got like an extra something for some reason. Aha, of course, yes. Yeah, that looks fine. Okay, this looks fine. Because I forgot the ampersand. It's fine. No. I should have stopped right away because I saw this issue where it should be. Okay, redefinition. of course there are sometimes the same values, so that's how it is. C90 of course is redefined. Okay. That's very interesting. Just not use fputs. Let's just use. I hate to put exits in code. It is what it is. This is not like not really quality code. Okay. Okay. So it basically works. It maps some region, but if we put something here, it should generate a file. Ooh, do I have space for this shit? Nearly not, and now it's already going out. So let's just look at it. And it became like some gigabytes in this little time. Okay. Actually, we have time. We have space for this. Why not? Okay. Oh, okay. This looks much better than we just say main and generate. And it should be like finishing this in just a matter of time. I'm actually using the same SSD for just like for my recording, so maybe this is actually ruining my recording. I don't know, I don't care. But there was space for it, I think. It's just fine. In the meantime, we can maybe here is the in the middle of the screen the real example, like this thing to open some file, seek, read something becomes this. So we should still open the file descriptor. We'll just use fopen. Then we will get the address 0 length. Okay. Len is output variable, of course. Read map private. Find the sector some of it. And of course we will just exchange these with the code that has been here, because here what they are doing is that they are creating a anonymous area, so it's not backed by the file, but we will be backed by the file. And of course these things are also like just there because of the anonymous nature. So instead of that, we will just do this variation, but we will still call this mprotect on it, so that we allow execution, and then we can somehow jump to that region. I think we will use inline assembly to jump to there, because there we can basically make a function around it that simplifies everything, and we don't need to think about the calling conversion stuff. So maybe that's better. And this is still not finishing it. I'm actually really not that happy. Oh, and it finished! How great! So look, we have our we have our 13 gigabyte data file. Oh yeah! It's crazy, but it's there. And if we look at that, okay. We have hex on it, I guess. This hex down. Ah, that's great. Have like number, like, I don't know, 100 bytes, and it should be this file. So it looks like it became what we wanted, you see, because I see the machine code here. So we have the starting machine code here. Of course, we are having little endian and bullshit like that in Intel. So that's why you are not reading this properly. Oh my god. We should have just like 1 byte character display, 2 bytes hex. Why there is like, maybe let's see. This is better. Okay, so this is how it's better viewed as. So we have this 67 FFA0, and then the 4 zeros, which is basically the address, 31. So this is the 7 bytes of the jump AX, and relative to this, so basically from here jump with EAX, and the thing here is that C0, like 31 C0 is XOR AX AX and return, and like nope return, XOR AX AX return, and so on and so on. So basically we generated code just as we wanted. Actually, if you do it the memory map this way, like as it is written here, you get like 4096 bytes of memory that you can write, and of course use this setup memory and protect something, and generate like that many, at most that many instructions here. Then you can basically make like a JIT compiler. So this is actually very useful for that if you want to do that. So stop here, look at the screen and everything, and you can maybe do that. But here we are not doing that. What we are doing is instead following this. So we should have like 0 length, that's fine. 0 and the size, okay, that's fine. Prot read, map provide, prot read, prot write, okay. I don't know if I need to write. I don't think we will need to write here, but why not? And I will just remove it, why not? So just make it right. Read. I use stops and only spaces behind. That's how it should be. So you make it readable. Then we don't need this anonymous shit. What we need instead is mmap private. And that's fine. Oh, that's not. And find descriptor and some offset. Find descriptor should be like F. And we don't need this setup memory actually. Okay. Because we need a fopen. Basically we need line 41. And instead of null, we are putting F here. Fine. What the hell is going on? Oh, fuck. Of course, I moved the file, but I didn't move the vim. So this should be like secondary. This is how we should have it. Yeah, I know. Okay, so just exit. Okay, we have it, and now we can save. Anyways, so we have web private. Ooh, maybe we are wrong. No, this should be like 0. Let me just remove the comment. I'll just say this is one page. Oh, so that's how it is. We remove these comments because we take care of bad comments. Okay. Some offset, so we will just say like offset. Okay. What just happened here? Ooh, it took for some reason very long time to write this file, and I have no idea what is happening. But it's crazy. Okay. It became good. I hope I'm not killing my SSD with this all kinds of bullshit. So okay. And prot exec. And now we should like jump and do this. I think what we should do is that, of course, after the we should also just accidentally programming my own language. This will help actually, people. Okay. It takes sometimes very long. It's crazy. I don't like it. Okay, so map private and jump cal and map region. So that's what we should do. That's the only to do in here? It looks like. And we should also close the file. Okay, and for that I think what we should do is let's call this load. It should be not new, just like. Let's call this load and run. Let's print it from maybe that section this one. But we should put it actually here. So that we can call it song actually from this band. I will put the songs in the description. Okay, so we will be load and running, and we just call this void run. No, it should be not void, but like int, and it should be like is returned on. We should not inline this. We should not have any local parameters for basically here for whatsoever, and then we can just inline a assembly here basically, or we can just make this a function pointer, and I always want to sort for that. So it should be like the return value, then the star and the okay. So it should be like the return value, then like this, and it has nothing. It should not be like this, just like. You don't need the attribute login and nothing. It's like let's call this ASM fun. Actually, we can just call it odd. How is it? Did I write this? isOdd. Because that is what it is, basically. problem is that the first parameter, it will be an EDI register, not the EAX. So that's kind of fucked up now. But we can put that in EAX because isOdd ASM, we can do an int, basically the same, just like not a function pointer, which basically will do a little code around it, and this will be like static int isOdd. What this is going to do is that we will call a function first. We will do here we will do a static volatile something temp int tmp. Volatile is needed so that the compiler doesn't optimize this sort. And what this is going to do is that we will do like a static doing here is that the int, how we are just saying this. Hardest things is naming things, isn't it? I will just call this like okay. What this will be is that tmp will equal to just a. So we will just call it a just function. We will just do return a. We can basically do put in x, and that is also okay, so this looks better. So after this, now we can basically just call the isOdd OSM. Fuck. What? Do you know what we will do? We will just do this. This is not what I wanted. What I wanted is GCC. Okay, let's just do another thing. Here we have like ASM. Okay, this is how it should be. So it's basically some. And this is only it. So this should work. Has it? I think so. So 5-star. Let's see if we have something. This F. 5-star F. So what the hell? Mmap. Shut what beacons. So it said like 0 lamp protreat map private. It says this just close. So it says 0 lengths. Oh, the length is this something. Is where it is. It's an int. This should be like this, I feel. What the hell is the length parameter? No, it's normal. It's normal length. We can basically do it. You basically do a get page size. But I don't like that actually. File descriptor. What the hell is going on? The no inline. Oh, this is just warning. Fuck. But we should basically not F open, but like open, I guess. Okay, so it should be like open, not open. That's fine. Oh, wrong. Okay, it should be like. This should be FD. File descriptor. Open data file. Now we can have FD here also. Okay. Where is the open? It's fcntl.h. Okay. Okay. Don't know what's the return value here. success -1. Okay. This is actually smart. So that it's different and it gives a syntax error. Okay. F close. I think we should not use F close, but close F. I'm pretty sure. Yeah, unisted. Yes. I have that. Okay. Oh flag. Oh fuck. Now it's open again. Flags. It's like O create or these things. All large files actually not that fucking simple. I should have generated this. I should have generated this. Should have generated the code, the data. No, because it would slow things down. So all of files, so this cannot be represented by an offset T, which is true, I guess. What the hell is offset T? This is like sys types. Let's see. It's 8 bytes, so it's actually going to work, which is very cool. So it's actually very cool. So offset T is T. Oh, okay, it's actually looking like it's gonna work. No inline is like, I understand what it is. It's just I need more parentheses here. Oh, this is taking longer than I expected. I have to say. So open makes an integer from pointer with the cast. Okay, so it should be like open. They have examples here, but I don't have it in my packages. Write only, create, trunk. Read only, this is what I want. Fuck yeah. Fuck yeah, this. Fuck on means Sweden is pretty Hungary. Just say. So, I think this should work. This is working now. Okay. So, what's happened is that we will do this isOdd on a number. Let's do this way. No. How to do it? We will just scanf a number in. I think this is how it is. Sometimes the feelings turn me on. I am the man who walks alone. I'm just sending. That's the format. What the hell? String format. Ooh, not scanf. Not scanf. I wanted normal scanf. Fuck yeah. It's just a typo. Okay. So basically we are scanfing the thing. But the map with address size, this should be like, instead of get page size, instead it should be, let's do it this way first, okay. Why I having to? Okay. Okay. Here we will do odd, even, whatever. We will just fix this. Which is not true. At least this is true. Okay. So what we will also do? Oh, yes. We will just fix this. So we have the number, and now we should be just like doing the thing. We have this mapped address, and it will be long enough. Like it will be currently long enough for this to work. So we will just do this in the. We are just needing to call set the isOdd assembly. It should be like the stylified map address. It should be like this. I just think. Now look up what is going to happen. Okay, let's go forward. And so we put the function here, we call it, we return the value, we put the value there. So we should now just say isOdd and num. And the number is like the number. Then we should we can actually use fputs that puts. So it's basically this. Or the means. So this actually is what we are doing. We don't need optimizations because we hadn't optimized the assembly. And the bulk of the code is just that assembly. So let's look what is happening. So we loaded. Ooh, I don't know why it became like 4009, but it's fine. For some reason that's what it got loaded. It doesn't seem to work. Let's see what is there. Okay. We need just try to GDP this shit. Okay, yeah. Cut it with 3. Segfault. Okay. What's the problem here? What's the problem here? Okay. This is not what I wanted. X. This is not what I wanted. What is on this address? Okay, it looks to be what we need actually. Just like X should have format. X. I imagine we should just do it this way. Format is a repeat count followed by a format letter. 1x. 10x. Okay. This is not how I want it. Byte. B. Bx. Yeah, that's the meat. So it's basically your code. So it got called, but it got segmentation fault for some reason, which is very unfortunate. But maybe there is some permission issue here, because the code is there. You can see it's there. Like this is the jump, this is the relative addressing to EX registers. No. Registers. So that rep+eax does not look like very good for some reason. This is actually okay. This is not good, because the rocks should be what? 3. It should have 3 actually at this point, so this is already very bad. Okay. Should have the 29. Restart. Yes. Okay, number is, what it be like 4 registers, and it does not become rep+eax for some reason. So I'm really not happy about this. So that's the first thing that's not working. But we are... I just didn't want to regenerate all the file again, you know? Like the assembly, that took long. Okay, is there a calling convention? Is there a calling convention where ex is the first parameter? Let's look fast call. Okay. That's not good. Let's look at ex. Borland register, evaluating arguments from left to right. Okay. The remaining arguments are pushed onto the stack. Okay. Fast cover. This is C++. So GCC and Slam can be made to use similar calling convention std call with the rep+ function attribute order mmap3 switch. Stack order is inverted. Oh shit. Color cleanup variant using C declaration. No, that's I don't need that. SSC registers. But C declaration basically. Oh fuck yeah. Okay, what we will do, it's complete bullshit what we have here actually. What we will do is that instead of this trickery, this put in Ajax and the temp and everything, this we will not do. This will be attribute no inline. Where the hell we can do that? I think in the YouTube it was like attribute no inline, just no inline. Okay. So it should be like a no inline function. So this is parameter in eddy something v information. This is that system v. Okay. So instead of doing this, what we will do is another assembly, and that will be fuck. This is like stack funny rat, and funny rat is having like this. Yeah. Should be like having this. And it should be like that we are adding to, not adding but move. And this is not Intel syntax but this AT&T. So it should be not to from, but from to. So we are moving from EDI to AX because it's 32 bits. And for some reason, we should still call that is odd lesson. It should work. Because it has no parameters, it has a return value, and it should fix its own stack, so it should work, actually. It expects in EAX because it was simpler to write it that way. I could write it to expect in EDI, just I was like, I don't want to think about that. So let's do GCC. what I wanted actually. Just it became smaller. I should have it in 20. I wanted to continue. Okay, so the number is 4. And now info registers. We have 4 in elx. So this is what we expect actually. And we should jump to ex. Okay, that looks like just fine. Because we were jumping to ourselves, that was forever lasting loop anyways. So instead of that, no, we were always jumping to the first. So still we likely have some permission issue. And this is like, okay, for registers, it's kind of working, but now this is like the isOdd ASM. We will step into. We got segmentation fault. We just can have 0 and we can like GDB ASM. I very rarely do assembly in GDB actually. Layout ASM. Okay, this is it. This is 8 plus. F0. For some reason, it does not really want to do that. Okay, restart. We just restart the program. Okay, this is good actually. We continue. We set it like 42, okay. Now we are here and now we will set layout. Yes. Okay. And there we have the call operation. So let's do next. Actually, here we are getting segmentation fault. But are we trying this? Are we? Again, it has 0 for some reason. Fuck it! Why? I really didn't want to write a move ADI EX. I just because actually if this is true, okay, yes, just do it. Delete this background somehow. Okay, 42 is. We are in the isOdd. Okay, so we have this and step into ASM. That is it. Okay. Step E next E. Okay. Sheeny. I used to remember this. So, next instruction. There is a move there into AX. Look, this shit. The compiler generated this code instead of. So basically, we have info registers. We have nice value here, the 42. And now, if I say, okay, if I say next instruction, the next instruction, like look at info registers, it fucking got 0. Why? Okay, so step in. We have this, and now what we are trying to do is to jump. It's a relative jump, so it's maybe actually not even working because the eax can be too big. It should be like rocks. Oh fuck. So I fucked it up anyways. So maybe I need to change the disasm because anyways, the code generation that I wanted to spare because it takes time to generate that huge file. But basically, it should be like a relative jump, 64-bit relative jump, because remember it's 12 gigabytes of data, and I don't think we can have that huge jumps actually. Okay, rethinking. Where is this? There is this little online example. We just put it like rocks here. What we are thinking of here? Quadword pointer. So it became the same actually, isn't it? No, it's X. So it's basically it should be rocks, and it should be 3 times that. Oh fuck! Oh fuck! Oh fuck! Oh fuck! So it's FF80 and these. Okay. Is it the same? What the hell? 64 FF. Oh, so basically we don't need the 67. You see? We don't need the 67. Oh, it's just the 32-bit prefix. Look. Oh, you don't need to generate the code. I just need to avoid the first byte. That's actually pretty good. So we can just jump into the middle of this. And that will be like 1 byte offsetted. Okay, that's fine. Yes. So what we will be doing is that it's basically the isOdd ASM. Let's say. Oxygen, great, not move, oxygen, one, things like that. So, this is very good. I was just joking, like word jokes, very bad. Anyways, so this way now, we are jumping one more address and we are avoiding that little 32-bit prefix. So we do not need to regenerate the code, but the issue is still that this becomes like a problem, that this puts this which is really bad actually. So what we should do, I don't know why it erases rip+eax. It's really crazy. It's crazy. I must say it's crazy. So okay, cc inline awesome call function pointer. Let's see how this is. Oh shit. Oh e. Oh. Oof, that's also very bad. This was very badly said. So let's look at what the God word is. Okay. I see. So it should be like this. Okay. I understand. It's like small. Let's try it this way. No, maybe. No. Maybe we need this shit. Okay. Function point instead of function pointer is isOdd awesome. Okay. The hell. So we will do this instead. Just look at what is happening. Okay, this is cool. We got 6 segfault, but I think the value is there. So we are progressing. So now it's only some kind of permission actually. I'm pretty sure. Really sure it's only just some kind of permission issue that we cannot run the code because it's actually if you put layout awesome here, we are here and basically we just cannot run the code. Well, what is it? There is. So, oh, of course, on that frame there was no source. Okay, so we are calling. And look, we have moving the EDI from EDI to EX. We have the EDI, we got the value there, and now this is basically for reg. You can see that the EX is having the value 42. I just erased it, but you can see it. See? 42. But, and now we can step instruction, and we are here. And if we would do this jump, the problem is that I don't think the problem is with the jump. I think it's the problem that we just cannot. What the hell is leave here? What the fuck is that? I see it. What the hell is leave? Why? Why leave is here? Oh my god, what the hell we are talking about? Why it isn't red? That's very bad. Okay. What the hell is leave? Oh, for some reason oh shit. Shit. Oh, for some reason it became C9 because I was dumb and wrote it here, C9, and it's 3.3. Okay, I remembered badly. Shit. It will work. But this is not the issue actually. The issue is actually not on this, but we don't have permissions. Just I wanted to fix this. So basically, we don't have permissions to run this code for some reason. XOR is fine, and this leave is bullshit. So, oh my god. Okay, we will just do what we want. Why not? I will do GDB from here actually. Just saying. So we are opening and we just write byte by byte again. Instead of C9, it should be like C3. Shit. Okay, we don't have C9. And we will also not add this fucking thing here, because then we can just basically do procs. We could actually do a move, but we already saw that one. Okay, so this should be not here. And then I know that I need to like remove a +1 from here, but just but the thing is that I will want to run not a +1 but something else, so actually a plus something. But I know the permission issue is the real issue, because the jump, I'm pretty sure it should work. But we will see, I'm just saying we will see. So let's do this. And here we are doing the poor SSD. 13 gigabytes of bullshit. Okay. Okay. No. It should be like, what the hell? It should be. Let's test this now. Oh, it says that main gen, but the issue is that I forgot this. Okay. Okay, it's fine, it's fine. Now I can do the main gen. Let's time it so that I know how long it takes. Anyways, so we are regenerating the assembly just because I fucked it up. It's good sometimes to remember things instead of Googling, but when you remember it badly, I should have been better Google that up, so that's how it is. It is what it is. I will just check my Hungarian traditional fireplace in there because I have fire and I don't want it to extinguish. Let's see. So it was actually beneficial for me that, look, the fire is in the background. So it was actually beneficial for me so that I had to go out. Okay, fine. Look at this thing, it's still going. Yeah. I should actually close the door of that so it doesn't happen. I just make it low. It's back. Okay, I'm back. Oh, it's finished, but I didn't exit. So it should be like something. Okay, it's segmentation fault, I don't care. But the file have been generated, which is fine. So now the file has been generated and we still get segfault instead of timing. It take like 2 minutes, oh my god. It's still faster than some days for the Python in the article. So we have segmentation fault. No, that's not what we want. Is that what we want is the breakpoint. Then what we want is to restart this thing. Yes. Then 42. Then we want the layout assume. And we can have info reg. We have the 42 in where we want. We step in and we have this. So basically this should be working now. But we can go and add 6 bytes to this and test if the XOR AUX is also not working. Because now if I would just say next instruction, I get segmentation fault. But if I do exit and go on XXX, here we can basically do a +6 as I said and go to a different code. Okay, it's fine, and then we are like step in and we get this operation and this cannot fail. That just cannot fail. Okay, so let's go here. Oh shit, what happened now? So we will just do a next instruction and it actually works. So that's interesting. So it's not a permission issue. It is not a permission issue. That's very interesting actually. That's pretty interesting. I don't really like this now because it tells me that there is some issue that I was not really prepared for. Okay, so we go next instruction. We returned here, and oh my god, this return is maybe not really good because that pop RBP will be not happening. So this is not good here. Okay, it will be a stack corruption actually, but let's do this and let's try to do the layout source, and we got something bad because we jumped into the ABP. Okay, so basically that's not good. Anyways, we can actually do the jumping by ourselves. I just realized with that value, that's 6. So we don't need to do that by the assembly code. We can do it by the C code, and I don't need to regenerate the whole shit again. That's actually good. So instead of +6 here, +6 plus. Okay. Okay, this will be working actually. So we don't need to regenerate the assembly because I fucked it up, and we will do it. Okay, we will do it this way. Okay, this is actually. No, this should be still. The offset is basically the where is the number? Okay, so we should have the TUI first. It's crazy a bit, but we need the number times 6. That's the offset, and plus 6 plus offset, and this should be also size t. So this is how it is. So we will use the C compiler calling thing here to do this properly, and this return, this should not be here. This is not the no return. If this would be C++ and we would mark this no return, that's where the compiler would not generate that pop, ABP, and red and those kind of codes. But because we are generating it and it's not marked like no return or something like that, then this is should be working actually, because here we are getting that return code and with the popping of ABP properly. And now we are jumping to the proper location, and we should get the return value in EX, and we should have basically everything properly. Maybe it has some errors. We will see. We will just see. So we will just do the GCC number. What is number here? What volume? Num, because it's not number, but it's num. Okay. And look, I use this offset, I use the 6. And this should be 3, of course not 6, because I'm just dumb. And this should work now, actually. So let's start. Let's say 42. And it says it's even. Okay. Let's say it's like 43. And it's odd. And it's like... Oh. Okay, it became 43. And this is also odd. And this is also even. And look, it's awesome fast code. It's very performant code. But it's... Where the hell I am? It's still 4 billion if statements, but it's not 4 billion, it's only 4,000 or something less. Like it's around 1,000 if statement now. So if we are giving in a bigger value like 2,000 something, that should like overflow everything and make it crash, if I understand it well. So let it be like 4,096. So it becomes a core dump because we jump into a location that we didn't feel. yet, because we only mapped the 4000 disk memory, and even like 1/3 of this by the value of the input is already valid. That's because we are not mapping the whole file. So we already implemented everything, except we are not loading the whole file because we are just doing the get page size. But instead of get page size, we just say like -1, but it should be like 0.32t reinterpret casted, just C style casted, because why not? And now it's not working because mmap mapped region address it didn't let us map that huge page for some reason. Oh fuck. Oh fuck. So now, in theory, everything is working except memory mapping that huge file. So what should we do actually? Oh my god. Oh, no, it's not int 32 address size. Oh, it's int. That's very bad. Because if it's int, that sounds very bad. Okay, this should be like u. The sprint info should be basically not happening, but before the GUI. Okay. Okay. Now this is looking like something. Look, it's working! And we have implemented this bullshit! I hope the video is still going on. It's still going on! Realign! And I have my own homemade wine just for this purpose. Because now we are going to drink a little bit. Because we successfully leaf coded the 4 billion if statements on Linux. It was already coded for Windows, and I like Linux much better, as you can see. Leaf coded, uncut, without literally any cuts, even when I'm going out for the fireplace to fill it with a little bit more wood. I hope you really like the fireplace. Look how awesome it is. Look. Ooh, it even have the Hungarian motifs on it. So and it's keeping the heat even tomorrow night. I'm not joking. That's true. That's how efficient these kind of things are. Anyways, so little village coding and cheers from Chono city. It's not city, it's little village town. So let's try some crazy number. And this is not working. That is basically fine. It's odd. Let's see. I hope you enjoyed this uncut video. Sorry for the Hungarian audiences. I wanted to make this in the English language just to reach a bigger audience. Maybe someone is interested in the code. I can upload it into some GitHub gist, or actually just go back and look at this. So again, we just have a main function, which, okay, we should like return 0 here. A final bug fix. And because when we are generating the data file, we don't want to generate also to also run the. Actually, we can do that. Why not? But you know, it looks like a little bit disgusting. I know that if someone is just entering minus help or something, they get like a 30 gigabyte file. That's on them. Why don't they read the code or watch the video? Anyways, so we are generating the code. We are just putting in a very huge. Oh, I entered -1 here. Anyways, sorry. Yeah, it's fine. Load and run. Load and run opens of data file. We're exiting if it's not possible, and even describing how to run this shit. We are memory mapping this. We're setting the executable flag on this memory. We print some things just for debugging if you are fucking up this code somewhere. TUI. The offset calculation is how we are jumping in middle of the assembly. So basically, this +6 is only there because I fucked up the generation as I didn't want it to regenerate and wait 2 more minutes or 3 minutes or 4 minutes or whatever. And again, nothing is happening and the video gets boring. It was likely long and boring anyways. And now isOdd and is odd or even, and we close the file. And the generation of the data file, we are basically, this is getting unused. It was the jump, the relative jump locally, but I fucked up this code, so I could actually just delete this and fix the code up. And here it's like 7 bytes or 6 bytes, sorry, so who cares? And there was this thing, of course, for the odd, we are generating no operations on red, and for the even, we are generating the zeroing of the ex, and in the ex we are expecting the input, the number. So basically that means that we are only zeroing the odd if it was even. So it becomes false when it's even, and true because everything that is non-zero is true because when it's odd. And then we are closing the file, and that's it. And that's it. That's really just it. Of course, here there is the function which is just assembly. Like we are moving from EDI to EX because of the calling convention on Linux 64-bit system. Is that the first parameter is in EDI. We don't have any locals or anything otherwise, so the stack only has this base pointer pushed and popped. That's probably because of the ASM blocks, but that's fine. And we don't want the return here by ASM, but let the function send to the return. And basically, the attribute no inline is only necessary because then I exactly know what's going on. So this doesn't get like inlined or something, and then who the hell knows what is in this EDI registers, you know? And that's it. So, and the print is just printing the things. Well, literally, that's it. That's it. And the isOdd is the function pointer just because I wanted to mark it as such so that I can at least document it somewhat. And that's it. I hope some people at least follow this video, and good assembling, good optimizing, good C++ lower level learning, and whatever you are doing, you can see you can leaf code these things. And cheers again. Goodbye.